So let's go to the other example. I want to model this one because I think that these are the models that in which you will encounter some issues, and these are the models that need to be problem solved. They overall will be beneficial and useful actually in your work. You can see that here we have another variation of our model, or for example this one on the right. I can say that the technique in modeling these parts are partially, or better say, mostly the same. And about this model, from the outside it's going to be pretty easy, pretty simple, but when we get in the inside we'll encounter some problems. So I will add a cylinder and then come into the properties parts, and then up until now I have been choosing 8 sides as it was better for us to manage and better for us to work with. But this time I'm going to actually increase the sides. Why? I'm going to tell it to you. And here, take a look at the reference. I want to create our details in symmetry of the both sides. So by increasing this number, it will be much easier. And as you can see, if I decrease the number, you will see that it will be hard to manage the type of geometry we're going to get. For this reason, I prefer to increase the number of segments, or sides better say, to 20. And also I'm going to increase cab segments to 4, and then convert it to editable poly, roughly delete the bottom parts and come up with only a plane. To create the outline of our model, I have to ring select the first type of edges, and with using ring command I will add 2 more edges here and decrease its width a little bit. Just to note, we can use symmetry in our work here just like this, but for this instance I want to keep that, and I'm going to select this edge loop that we created, in face mode. And as you can see, if you remember, we have to extrude it up to create the whole outline of our model that we want. And for the second extrude, I have to actually exclude the 4 faces that I want and just apply it, and there you go. You see how it's getting its overall shape here. If I apply Turbo Smooth, you can see it's all blocked out. But now the thing that is here is I want to further sharpen these edges that I showed you in the reference. So I will now apply the hard surface material to our model. So to do what we want now, I'm going to select Swift Loop again and start to add some restricting edges as we have done in the previous videos. One here, and also on the other side. Just like this. So now with Turbo Smooth, I take a look at it and I think it's good. You remember in the first session, as I told you, when we apply the hard surface material and give it proper specular level, and you will see more details from the models, and the shading just gives away the issues that our model may have, that otherwise if we do not have any shading effect we wouldn't notice, and we can easily be mistaken. So there's 2 problems. The first is that we have some shading issues on the top view, and the second is that our holes are not in symmetry but we can correct it later. Now, I want to focus on the more distorted part of our detail here. So, how to fix this? The first thing we should know is to determine how it is caused in the first place. And the reason is these three vertexes that are floating right here. So we can weld them together and do also the exact same thing on the other side. And now if I apply Turbo Smooth, you see that it's more like a circle shape and it's no more distorted here. But still, we have our hard surface material, and it is in fact showing some other issues, shading issues that we are getting here. What we did just seconds ago was to target weld the three vertices that were floating into one, as you can see, and we got the circle shape that we wanted. But again, here we are getting this shading issue. And the reason for that is actually it's here the same thing and it's the same principle. We have three vertices that aren't close to each other. And what does that mean? And that means, I think you should know this, and that means the curvature that we have is being limited. And all we have to do is to create some distance, more distance between our vertices, and you can see it's a little bit better now. But here we're still having our problem, and we can furthermore create some more distance between the edges. We can take another step and actually prevent those vertices to be floated right away, and we can use our cut tool to connect the vertices to the corner of our mesh. And now you see, it is just as smooth as we want to have. So now, what we see from far above or far away is that we have a smooth curvature that can be maintained using two techniques that I just showed you. We can both connect the floating vertices to the corner or just create more distance from each other to maintain more room for the curvature to be applied. So now I'm going to use my Swift Loop tool and apply more sharpness to the edge that we just worked on. So I think that's enough to work in here, but if you pay just super close attention, you will notice some inconsistencies in the shading effect. But I don't see any point to continue working in this part of the model further in this section that we are currently in here. Just to remember, you can do this in two different ways. Now, I move on and ask another question. How can you control the curvature on those edges? Of course, by adjusting the edges, right? And if I select only those edges that I need and deselect the others and move them onto the side and turn on Turbo Smooth, you will see that how it applies a different curvature effect. So remember that I told you about that we have two problems, one being the edges, the curvature, and the second being the symmetry. I now want to correct the symmetry, and for that I will select and actually delete the unnecessary parts. And for the symmetry, I'm going to actually use double symmetries to get what I want. See, it's just mirroring right exactly on the other side of it. So just as I said before, you can actually spot some like artifacts and small shading inconsistencies that are still there if you take a closer look, but these are not major issues, and we won't be able to notice them at all in the proper distances. So just to review one more time, if we have some vertices that are close to each other on a curved surface or mesh, they will affect the curvature effect and shading effect on their own. And now I will just show you the exact same thing on the other side of our model. You saw the different shading effect, and now I will just remove the edge loop that I added right now, and then apply more distance between the edges that we have, and then again add our preferred edge loop, and there you go. It's all ready. So I think it's pretty enough for this example, and let us move to another example that we have. I want to create this one, and before I create the plane and start modeling, I want to give you a description of this model. You see that here we have a curvature and we have a hole as a detail applied on the model. So now I add my plane here and then go, as usual, apply my hard surface material for us to see better about the shading, and then convert it to editable poly, and I will add a connect command and add 2 edge loops here, and then I will put 2 from the other angle, and then I will just adjust the distance as I want, just like this. Okay, so now what I'm going to do is to select the middle face and extrude it upwards as we have in our reference. And then here, I want to scale it a little bit in the x-axis and just create and roughly block out the shape that we had in the reference, just like this, and a little bit of adjustment. So, and here we have to apply 3 more edges that we're going to discuss later, and then I will create our reference n-gon and snap it to where our corner edges are, and what I want to do now is to basically move our edges, or better say move our vertices, and snap them to where our reference is. But there's a point here I'm going to demonstrate to you. As you clearly see, our geometry is all over the place. Why? Because first we are in 3D perspective, and also we are using 3D mode in Snap, or 2.5D mode in Snap. As you see, if I just use the snap tool and snap our vertices to the reference, our model, our geometry will also move on the axes that we actually do not want. We just only want to move our vertices in 2 dimensions. Here they are moving in 3 dimensions, and they move to a place that we don't want. But if you just move to a 2D orthographic view using the 2.5D snap mode, this time you will see that it's only moving in the directions or on the axes that we want, on the 2, them being y-axis and x-axis, and they will not be affected actually by the z-axis. And so to review once more, we used the 2.5D snap mode and went in an orthographic view to limit how our model will behave when moved by snap. So the thing we have to do right now is to continue the process and select our vertices like this and just move them, snap them into the place we want. You see, here they are not being misplaced by any axes that we do not want. They're just exactly behaving as we want them to behave. So now we have actually created the circular shape on the top part of our model. And now I just scaled down our reference Ngon because I need to create a hole on the surface. So first of all, I connect these two vertices, and then I will cut through the geometry just as we have done in previous examples to be able to cut our Ngon through the model. But now I will just scale up our Ngon to follow the rule that I said previously. Whenever I want to create a hole on the surface, like a circular shape, it's better to make it bigger in the first place and use it as a safe loop or preserving loop. Now, I will delete our reference Ngon, and then I start to adjust the geometry. I will cut the vertices to the edges like this. And then after that, I will delete, or better say, dissolve the edges, the unnecessary edges that we no longer want to be. And you see that we have not yet applied symmetry. And you might ask, when should we apply symmetry? Yes. First, it's better to create the thing that we want and like inset, and then extrude inwards for the amount that we want, and now apply the symmetry. And when I apply the symmetry, hit flip, and you see, yes, that we have applied our detail on the mesh that we desire. And then now I will start as usual to sharpen the corners to get the effects that I want. I add one there, and also inside our hole that we created on the outside part. And then I want to basically add definition to my model. And basically the thing I want to do here is to add some chamfer effects, as we talked about earlier, that I'm going to chamfer operation for 2 times. And here I will just do the same thing. I apply 1 chamfer and then the second to preserve the details that I want. And then even I can remove the other edge loop that is not necessary. And yeah, I think that we can remove that and then add the chamfer effect that we want on this to preserve the sharpness. Now there's one thing on the bottom part when I want to create an edge loop. As you can see, there's going to be a bit of a problem, and that is why we have to use the connect tool to be able to properly add an edge loop here. And this is because that we are having some topology issues down there, as I will show you and actually fix that later. But it's not just a thing that I want to do right now. It's about just a triangle that is down there. Now with Turbo Smooth on, you can see how well it is. And if you now if you take a look in here, you spot 2 triangles, right? The thing that I want to do now is exactly to merge these vertices that are just down there cracking the topology as we saw earlier. So I weld all of them together, and also these two vertices. Also, I weld them together, and so I select this edge loop and add our chamfer effect to that. I want to create that sharp edge which we have on the top part of our model on here. So, and add another one to preserve them. And now I turn on the turbo smooth, and as you can see, we are getting exactly what we wanted, but there's something else. I think you just noticed the shading issue. There's another problem here. You remember that just a second ago we welded some edges together, and now you see that despite we only end up with one edge or one vertice on the bottom, we are having two edges right on the top. So now I have to now dissolve them and just repeat the operation right now, because we added the chamfer effect when we hadn't been done dealing with the bottom part. So now it's all good and all okay. So now it's looking pretty cool, just as I want. And I think that's enough for modeling this part and this example. And as you can see, we are slowly getting more and more complex. So now in the reference, I want to create this one. As you can guess, as you see, the base or the blockout is very similar to our model, but there will also be some major differences that we will see. So to create this example, I will, just like the other example, add a plane and apply our same material just as before, and we'll just play with the scale a little bit. And I believe you should know here that why we have been choosing to create edge loops with connect command rather to get an inset and get the blockout done, because if we use the inset, we would get diagonal lines, and diagonal lines means, you know, a circular shape, not a rectangle shape anymore. So just as before, I want to just adjust it a little bit further, and now select the face and extrude the face and bring it up just like that. And now I will select this face here and then get an inset from this side. But there's one thing that I have to do before, and it's so important in the order of the things, and that is to first maintain circular shape on the top of our model. And for that, I will use the same workflow as before. First, I just adjust a little bit, and then I will use, just as before, the connect command to add 3 edge loops here, and then add the n-gon, snap it to the right place, and then bring the vertices, turn to 2.5 dimensions, and then connect the vertices just like this. And now I will do the inset to the inwards like this, and for this part I can just cut the vertices in here and then to the edge, and same for the other side of our model, and then start to dissolve the unnecessary edges with the target weld tool activated. I can one by one, target weld the vertices down the bottom, and I believe that I should change the scale of our blockout to be further in shape of our reference image. And just like before, I have to extrude inwards, just as we did before in our previous example. And now, again, do the symmetry flip and increase our extrusion, and now we are getting just the right blockout shape to work with and polish it. Now, as before, again, I start picking up my Swift Loop tool and start to sharpen our edges that we have. Let's start in the Let's start from the inside. Put one over there and one over here. And I'll just keep going, adding some edge loops. And for example, I want to add an edge over here, but then it seems that this part of our mesh is having kind of problems. So I select the edge and use the connect command. As you can see, we still have a kind of a problem. It can have actually a variety of reasons. One might be because our vertices haven't been target welded, and there may be actually some other problems. But now, in our case here, I can actually continue and take an easy route. How? I keep my symmetry and just, again, select my Swift Loop tool and add the loop there and just rotate, get to the part that is problematic, and then pick up my cut tool and then manually cut it through where I want. And just like this, it's going to work. And just adjust it a little bit. So here, I decided to take the easy route here, and then I want to continue adding my loops again with Swift Loop, one in the top part to preserve more sharpness. And then let us check with the Turbo Smooth, and I just think I have to adjust a little bit our symmetry to be closer to the reference. I'm going to reduce symmetry range, and then let me bring up the reference image again. Take a look. If you see it, the edges on the inside, they are so sharp, and the edges on the outside are a little bit more circular in shape. So what I have to do is actually pretty easy. I go into my model and then select the edges that I just added and remove them. And then I will convert again all of this model to a new editable poly. And then I have to even remove the symmetry line that we got here. And then if we apply the Turbo Smooth, we can clearly see that we have achieved the exact result that we wanted. So I think it's enough for this session and this example. Let's move on to another workout.